Hi guys, I'm going to continue with the series quadratic equation that I started. So today I'm going to be looking at symmetrical properties of roots. I have a question. The question says, given that alpha and beta are the roots of the quadratic equation, 2x squared minus 4x plus 3 equals to 0. I should evaluate the following. So I'm going to start this way. I'll pick the first, which Roman figure 1, it says I should get alpha plus beta. Now, just follow me and see what I'm going to be doing now. This is talking about sum of roots. Therefore, since we are told that the roots are alpha and beta, it therefore means that x is actually equals to alpha. That is one of the roots. Then x, of course, is beta. Now, working it back to get the equation, this is what I'm going to have. Picking alpha to the other side so that I will have this expression. The same thing is going to happen here. I will have this expression. Now, I have two factors, which when I multiply, it should be 0. All right, so I have x minus alpha into x minus beta. Of course, all when multiplied is equals to 0. Now, when I expand, I'm going to have x squared minus alpha plus beta, then x, then plus alpha beta. Now, I actually expanded and now factorized. I think you should be able to do this, okay? Now, but one thing I know is that the general format of a quadratic equation is actually ax squared plus bx plus c is equals to 0. Now, these two equations look alike, but the issue here is that the first equation, that is this one, has a coefficient of x being 1, x squared actually. Then this has coefficient of x squared a. So I need to make the two equations to look alike. That is this equation 1 and this equation 2. Okay. So what am I going to do to equation 2? I'm going to divide all through by a. So that I'm going to have ax squared over a plus bx over a plus c over a is equals to 0. Now, at the end of the day, I'm going to have x squared plus b over ax, then plus c over a is equals to 0. Of course, hope you know that even if I put this, it's still going to give me 0. So take note of that. Right. Now, they actually look alike, very similar. So this is x squared minus alpha plus beta, x then plus alpha beta is equals to 0. Now, by comparing coefficients or terms, you will now agree with me that minus into alpha plus beta, of course, coefficient of x must be equals to b over a. Hence, we can now say that alpha plus beta is equals to minus b over a. Then alpha beta is easy to pick, is equals to c over a. You see these two? Very important, okay, for our own solution here. So, like I said, alpha plus beta is equals to minus b over a. Then alpha beta is equals to c over a. Take note of this because we are going to be using it very well in all our work under the symmetric properties of roots. Now, to actually work this question, I remember we are given an equation. The equation is 2x squared minus 4x plus 3. So I have 2x squared minus 4x plus 3 is equals to 0. Now, when I compare with the general equation of general quadratic equation, I'm going to have ax squared plus bx plus c is equals to 0. Comparing the terms, in this case, I can now see that my a is equals to 2, my b is equals to minus 4, then my c is equals to 3. All right, very simple. So therefore, it means that I can get my alpha plus beta. So alpha plus beta, which is minus b over a, will be minus into minus 4 over 2. And of course, the answer is minus 2 minus into minus 2. So I'm going to have 2 as my answer, right? Then for that is Roman figure 1. Then Roman figure 2, I was asked to get alpha beta, which is C over A. Good. Now what is C? C is 3. So it's 3 over 2, which is 1 whole number 1 by 2. So I'm done with this. Very okay. Now I need to get the third question. The third question is alpha squared plus beta squared. So I have alpha squared plus beta squared. Now, since we are not expected to go find the actual value of alpha and beta, this is what you are going to do. You are going to play around with this so that it can give you an expression in terms of either the sum or the product. Okay? So therefore, I'm going to come down here. What will I do in this case? I will expand alpha plus beta all squared. Now, in expanding this, I'm going to have alpha squared plus alpha beta, then plus beta squared, which when I bring it together, I'm going to have alpha squared plus beta squared, then plus 2 alpha beta. Now remember, we expanded alpha plus beta all squared. Now if you check it out, this is what I'm looking for. Can you see it now? So what I'm going to do, I will make it the subject formula so that I'm going to have alpha squared plus beta squared to be equals to alpha plus beta all squared, then minus 2 alpha beta. What happened is I pick this, all right, down to this side, okay, down to this side, okay. That is how I got this expression. Now remember, I told you I'm going to be writing it in terms of the sum and product. Now look at, this is the sum and this particular one is the product, okay. So therefore I'll come down. I know that this is alpha squared plus beta squared is equals to alpha plus beta. I found it already. Look at it. It is 2. So I'm going to pick it here. I'll put 2 all squared. All right. Then minus. Now let me go to alpha beta. Alpha beta is 3 over 2. All right. So it's very easy to get. So minus 2 all 3 over 2. Now this is what I have. Now working it further, I have alpha squared plus beta squared is equals to 4. Then this cancels, this is going to be minus 3. So the answer is going to be 1. All right. So alpha squared plus beta squared is equals to 1. Very simple. Then let's rush to the fourth question. The fourth question says we should look at analyze alpha plus beta and beta over alpha over beta, beta over alpha. So coming down here, I have alpha over beta, then plus beta over alpha. All you need to do here, just find the LCM. Find the LCM is alpha beta. Now when you work it out, this is alpha squared plus beta squared. Now recall, we've gotten our alpha squared plus beta squared already, okay? Alpha squared plus beta squared has been worked and we got 1 as the answer. Then alpha beta has actually been worked too. We have 3 over 2. So 3 over 2. It's just a matter of substitution. So I'm going to substitute. What I'm going to have now is going to be 1 all over 3 over 2. All right? So my answer is 2 over 3. This is very interesting. So you can go over it many times to really understand it. I'm going to be solving other questions, okay, that look like this but more complicated in the next video. Thank you for watching and do not forget to subscribe.